Title: The hardware nobody talks about. Subtitle: Why AI is really a memory story. Every week there's a new AI chip announcement. More flops, more parameters, more benchmarks. But here's what nobody tells you: the GPU is not the bottleneck. The memory is. This is the memory wall problem. GPU compute has grown 90,000x in 20 years. Memory bandwidth? Only 200x. You're building a sports car with a fuel line from a bicycle. High bandwidth memory, HBM. It's stacked DRAM, pixels away from the GPU core. The H100 has 80 GB of HBM3. The B200? 192 GB of HBM3E. But here's the kicker: SK Hynix makes 60% of it. Micron makes most of the rest. This is a duopoly with no spare capacity. Think of AI like a Formula One car. The model is the engine. The GPU compute is the engine cylinders. But HBM? That's your fuel line. Doesn't matter how powerful the engine is if fuel can't flow fast enough. And right now, the fuel line is the bottleneck. NVIDIA knows this. Look at the H100 versus the A100. Same arch, but the H100 has 2.4 terabytes per second of memory bandwidth. That's 2.5 times more than the A100. That's why training GPT-4 on H100s is 10 times faster, not because of compute, but because of memory. And every major lab is building their own. Google's TPU? 15 exaflops of AI compute. AWS Trainium? Meta's MTIA? They all have the same problem: they need HBM, and HBM supply is tight. TSMC's CoWoS advanced packaging is the real capacity constraint nobody talks about. TSMC's advanced packaging, CoWoS and SoIC, lets you mount HBM directly next to logic. It sounds simple, but these are 12mm by 12mm chips with 100 micron gaps. Yields are brutal. Capacity is tiny. Every new AI chip needs more of this, and there's a waiting list. But it's not just one chip. Training large models needs thousands of GPUs talking to each other. PCIe 5.0 gives you 128 GB per second. NVLink 4.0? 900 GB per second. That's why NVLink switches are sold out. The interconnect is as important as the chip. And all of this consumes power. A single H100 data center GPU draws 700 watts. A 10,000 GPU cluster? 7 megawatts. The new 100 gigawatt AI data centers being planned? That's the power output of a small nuclear reactor. We're not hitting a compute wall. We're hitting an energy wall. So here's the real supply chain. SK Hynix and Micron for HBM. TSMC for chip manufacturing and packaging. ASML for the EUV machines that make it all possible. These three companies control the bottleneck points of the entire AI industry. Not NVIDIA. Them. Next time you see an AI benchmark, ask, what's the memory bandwidth? What's the HBM capacity? Because the GPU gets the headlines, but the memory wall is what actually limits how fast AI can grow. That's the hardware nobody talks about.